Hello, for this question they're asking you to put y equal negative x squared plus 4x in a particular form, and what you need to do in order to make that work is to complete the square. So let's go ahead and look at completing the square. Now when you complete the square on the expression that we have here, what we basically end up doing is we take half of the linear coefficient and then we add it and then we subtract it. Now the reason we add it and subtract it is the overall effect is we basically added 0. So if we add 2, subtract 2, the overall is we added 0. Now the way you complete the square is you take half of the linear term, and half of the linear coefficient is, half of 4 is 2. So this would look like x plus 2 quantity squared down here. So half of positive 4 is positive 2. Now if you FOILed this out, this x plus 2 times x plus 2, you would get x squared plus 2x plus 2x plus 4. So really when you decided to square this, you added 4. But again, if you add 4, you have to subtract 4. Whoops. Subtract 4. So when I'm completing the square, then I have y equal x plus 2 quantity squared minus 4. Now this almost fits the form here that we're looking at, y equal a x minus h quantity squared plus k. But in our case, we don't need to put this in when you put your answer into my math lab, but there's an implied 1 here. So what we have for our vertex then, so this is what goes in this box, and then pretty soon you'll ask for a vertex when you graph your parabola, and our vertex would be at the opposite, because the negative means opposite, of positive 2 is a negative 2, and then negative 4. And the reason we don't do opposite on that is if you fit the form here. So that's my vertex in is negative 2, negative 4, and when we graph it we know this is a parabola opening up because I have a positive x squared, and then we look for just one other point on the parabola, and we could look, let's say, plug in an x equals 0, and if you plug in x equals 0, you have 0 squared plus 4 times 0, which is 0. So you have a parabola opening up with its vertex at negative 2, negative 4, and it also goes through the origin. So that's kind of the information that you need to graph. But the whole idea behind making this work is that completing the square. And again, completing the square is our important thing here. Hope that helps. This is another completing the square problem, but this one is a little bit different because I have some other coefficients that I need to worry about. So for this one, let's go ahead and look at completing the square on our original problem, y equal 2x squared minus 12x plus 14. Now before we get started with this one, there's a greatest common factor that we can work with, so let's go ahead and pull out the 2. So once I pull out the 2, I'm going to be left with x squared minus 6x plus 7. So really the part that I want to complete the square on is right here, but I also do need to remember that I have the 2 there as well. So let's go ahead and pull that 2 out front again. And then I want to think about, in parentheses, I want to take half of the linear term. Now half of a negative 6 is a negative 3, and this is my perfect square. Now let's think about what this really looks like now. Now remember, we're going to complete the square. You have to add an amount and subtract an amount. Oh, I messed this up already. In order to take y equal x squared plus 6x and to put it into the form that they indicate up here, you need to go through a process called completing the square. When you complete the square, basically what you're trying to do is to take this particular form that they give you and to make a perfect square trinomial or binomial out of it. So what we'll do is we'll start with y equal x squared plus 6x. And the way we complete the square is what we do is we decide, okay, I'm going to add some number to make this a perfect square, And because you add a number, you also have to subtract a number to keep a balance. Now the overall effect here would be, let's say, add 2, subtract 2, so the overall sum is 0. So that's kind of what we're keeping in mind here. Now the number that goes here in this blank would be half of 6. It's always half of the linear term. So half of 6 is 3, and then I square that value. So right here I have a 9. But if you add 9, you also have to subtract 9. So that keeps that perfect balance there. So if this linear term right here was, let's say, a negative 4, half of a negative 4 would be a negative 2. Negative 2 times negative 2 is a positive 4 would go here, and then you'd subtract 4. So it's always half that linear term. Now when we look at this, we have y equal x squared plus 6x plus 9 that I want to factor, and then I have this minus 9 off to the side. Now rewriting, I have x plus 3 quantity squared, because x squared plus 6x plus 9 factors into x plus 3 times x plus 3 minus 9. Now the form that we're trying to get this in, and again I'm pulling it right from up here, is y equal a x minus h quantity squared plus k. So hk is the vertex, and if you notice here, the vertex is shown basically by looking at the x-coordinate is the opposite. That's why there's a negative sign here. The opposite of whatever follows the x, and then the k value, but not the opposite. So for our case, our vertex is going to be negative 3, negative 9. And I know that this is a parabola opening up because a parabola opening up has that positive leading coefficient. So let's go ahead and take a look at that positive leading coefficient. Let's see if I can get my pen to work. Positive leading coefficient right here is y equal positive x squared. So again, this is a parabola that's going to open up. If that was a negative x squared, it would open down. And then I look for one other point on the parabola. So for instance, we have y equal x squared plus 6x. I could choose an ordered pair. It could be any ordered pair, but let's go ahead and choose a 0. If I plug a 0 in here for x, I'll get a 0 back out for y. So when I graph this, I have a parabola opening up. Let's say this is negative 3, negative 9 right here. And it also goes through the origin, 0, 0. That's this point over here. It opens up. So when you graph it, choose your graphing tool for an upward parabola. Make sure its vertex is properly located and it goes to the origin, and you should be set to go. This is another completing the square problem, so let's go ahead and look at the difference. So again, we're going to complete the square here. Now when we complete the square, you need to keep in mind that the leading coefficient has to be a positive 1. So in our example, the leading coefficient is a positive 2. So let's go ahead and factor out that positive 2 out front. And then once we factor out that positive 2, I'm left with x squared minus 12x, or actually we factored it out, so it would be x squared minus not 12x but minus 6x. And then over here, I'm just going to leave this plus 14. So I'm only factoring out the 2 from these two terms. Now the reason I'm leaving the plus 14 over here is so eventually I can combine it with, whatever it is I used to complete the square. So working, same problem, I'm going to have that value of 2. And now here is where I do the completing the square. So remember, I want half that linear term. So half of a negative 6 is a negative 3. So this is going to look like my x minus 3 quantity squared. Now you might look at this and think, oh, well, when you complete the square, here you get x squared minus 6x plus 9. And you might think, okay, I need to add 9 here, but really, remember, there's this 2 out front. So really, you don't need to add 9. What you really need to think about is how you actually added 18. So the plus 9 would go in here, and then you need to realize that you actually added 9 times 2, which is 18. So to compensate for adding 18, you need to subtract 18. So you'd have to subtract 18 up here. I'm going to run out of space. So we'd subtract 18. So down here what I'm left with then is 2 times the quantity, x minus 3 quantity squared. Negative 18 plus 14 is a negative 4. Now that is what goes here to complete the square. So that would be an example of completing the square, but again you have to be really careful with this 2 out front, because the overall effect of taking negative 3 times negative 3 is you get this positive 9, but it's actually positive 9 times 2, positive 18, and I have to compensate for adding 18 by subtracting 18. So this is a parabola that's opening up, and I know it's opening up because of the positive 2. So parabola opening up. Now its vertex is going to be at this ordered pair. Now remember, for this ordered pair, I'm going to have, from my general form, a x minus h quantity squared plus k. So for my ordered pair, my center is hk. So it's going to be the opposite of what appears here, which would be a 3 and negative 4. So when I graph my parabola, I need the point 3, negative 4, and then I need one other point on the graph. So if we plug a 0 in here, I'd get 2 times 0, which is 0, minus 12 times 0, which is 0, plus 14. So 0, 14 would be another point. So it's a parabola opening up with a vertex at 3, negative 4, going through the point 0, 14. Hope this helps.